Thanks everyone for attending the Data Architecture Virtual Chapter today, our first meeting of the year. I really want to thank my friend Ike. He came on today and he's going to do a great presentation for diving into Azure Data Lakes. If you need to get in touch with me, you can email me at rob@sqltigers.com, or you can email Kenny at the Virtual Chapter Data Architecture. We'd like to thank Nutanix. They're our sponsors. They give us money and they do a lot of great things for our chapter. They help us put them on. Thank you, Nutanix. If you have a chance, please visit the link down there, bit.ly link, SQL and Nutanix, and click around and check out their products. If you want to see the sessions for PASS, they have a USB drive you can buy. And you just go to passboutique.com and you can order it. Upcoming virtual chapter webinars. There's a lot of them. I would recommend just, if there's one here, sign into the PASS website and you can just click on the particular chapter and check out the meeting.
Hey, Rob, can I add something?
Yeah, go ahead. Yeah, sure.
So you said to get the USB drive for the sessions, but PASS last week just released about 7 sessions as part of their Best of PASS series. They took some of the highly rated sessions and they released them for free on YouTube. You can check their blog for that. Oh, wow. The reason why I know that is actually I spoke twice at PASS and one of my sessions is part of that. And so you can see one of my sessions for free today if you'd like.
That's great news. Wow. Thank you, Ike. Let's get back to here. Let's see. Oh, yeah. PASS has a lot of virtual chapters. I'm sure there's got to be something out there that would interest you. Here's some of them. They're, they're just great. A lot of free sessions, a lot of free learning. And upcoming SQL Saturdays. So if you're in Tampa, they have one up in there. It's pretty cool. People always, that's how I met Ike actually. People always going to SQL Saturdays and, sharing good information. If you have time, sign up for one, test it out. It's a great learning experience and networking with other people with the same interest. And with that, I'd like to switch over to Ike. Let's see, we're going to try this. Change the presenter to Ike. And I really want to thank you for coming on today. It's always
Rob,
great to hear from you.
Rob, I would do anything for you. You are the nicest guy I know.
Really? Wow.
Yeah. Yep. I would be glad to do anything you ask me to do.
Well, we need to get together when we go to something. I'd like to do that. Yeah. That would be fun. Sure.
Okay. So I'm grateful that 75 of you decided to join us today to learn a little bit more about Azure Data Lake. Before I do that, though, I did want to mention something that I do for the community. It's called TIG, and let me just show you. It's the San Diego Tech Immersion Group. It's a meetup, and if you go to sdtig.com, can you see my screen?
Yeah.
Yes, we can.
You can, great. So if you go there to that meetup, I know it's in San Diego. People come in person, about 50 people a month come in person, but we also stream all of our meetings online. And what it is a technical book club. And what we read a book, and the book we're reading right now is R for Data Science. So we're reading this book right now. And so the reason why I'm telling you this is if you want to learn R and you want to learn it with other people who will answer your questions and interact with you, message you, you can buy this book, R for Data Science, read the first 116 pages, and then sign up for our February 27th meeting, which will be at 6 p.m. Pacific. So you can join us. And then we'll send you the YouTube channel where we'll screen things. And you can join us. And so we're going to do this book over 4 months, all the way through April, maybe even May, one section at a time. And then after we're done with this, we'll do something on Docker. And then after we're done with this, we'll do something on Python. So please feel free to join us. And if you would like to know all the things that we do, including any YouTube videos that I make or anything like that, if you go to CraftingBytes.com, at the bottom, you'll see sign up for updates. And if you put your email address in there, I send an email out every other week. So I won't spam you, just like 2 or 3 times a month. And I remind you of the book club meetings that you can get online, and I tell you about any YouTube videos that are released and things like that. So Kenny also just looked up that best of pass URL that he put in the chat window, if you can't see that in the chat window. But this is some of those sessions that I told you about. Kendra Little, you guys know her, she's really smart. Ed Leighton Dick, you know him. Alberto Fiari, you know him. Like Melissa Coates, all these great names. Honestly, I'm probably, one of these things is not like the other one. That's probably me right there. But anyway, I'm grateful to be included in those. And you can see all these sessions for free. They're all great. Okay, so with that said, let's talk more about Data Lake. By the way, I hope that R thing excites you, because I hope you join us, because we're having a lot of fun doing it. Okay, so I'm going to assume that maybe not everybody here knows what a data lake is. And probably a very succinct quote about data lakes is this guy, James Dixon. James Dixon is the CTO of Pentaho, and he coined the term data lake in about 2009. And he said, if you think of a data mart as a store of bottled water, cleansed, packaged, and structured for easy consumption, the data lake is a large body of water in a more natural state, which is a very polite way of saying that a data lake is a collection of a ton of data for your organization that isn't cleaned yet. That's all. Or it's in various states of cleaning, right? And you might look at that and say, well, why would we do that? Like, wouldn't, you know, if I had to choose between drinking lake water or drinking, you know, bottled water, which one would I want to drink? And the answer is, of course, we drink bottled water, right? So why even have a data lake? Well, the answer is we're starting to do a lot more exploratory work with our data, meaning it used to be in the old days, we would rely on a data specialist like a DBA or maybe a data developer or an executive to tell us what data was valuable. Like if you talk to a CFO, they're going to be interested in accounting data. And if you talk to the marketing person, they're going to be interested in sales data or conversion rates. And if you talk to the HR person, they're going to be interested in employee data, right? And so the HR person would say, we need to know more about retention. And they go to the data specialist and they'd say, hey, give me more data on retention. And the data specialist would go and try to find that and give it back, right? But the reason why we have data science is because we want data experts to be more proactive in determining whether data is influencing our organization and what kind of hidden areas of data might we take advantage of in order to gain a competitive advantage or in order to retain customers or in order to do any of those things we talked about. So it's mostly offloading some of the executive responsibility down to the data scientists, right? Well, that data scientist or data analyst, we can't possibly clean all the data that that person is going to be interested in. And so that person, that data scientist, is more likely to do their own cleaning. They just need a place to know where the data is. They would like one location where they can go find it, right? And that's the idea behind a data lake, is to give that data analyst or scientist a single location for all the data, and it can be dirty, and they can take that data and they can bring it into SAS or JUMP or R or Python or Tableau or Power BI or whatever tool they're using, Excel, 90% of the time it's eventually in Excel. They can, and those people are used to doing their own cleaning. They don't like it, but they're used to it. So they have all these scripting languages like R and Python that they use to clean it, and then they'll discover something about it. And then once they discover something about it, they'll hand that discovery back over to the data specialist, like a DBA, like you and me, if you're a traditional SQL background, and they'll say, hey, this data is important. Now, please make an SSRS report or a Power BI dashboard, or put it in the data warehouse, or put it in a data mart, or put it in an analysis services cube. So basically they'll say, I cleaned it by hand and it took a long time. You cleaned it automatically, put it in a location the rest of the organization can use it, and then give it to them in an easily digestible way. So I hope that made sense, and that kind of gives you some idea about why we have data lakes and the idea behind it. There's another reason why we have data lakes, and that is that data tends to be very difficult to clean and move. And so that's why we actually can't clean and move all of it, because if we did that, we would spend all of our life cleaning it and none of our life using it. And in addition, if we cleaned and moved data all around, we would saturate our network pipes. So the last idea behind a data lake is that it needs to be a storage location where we don't have to move it all over the network to use it, because the network can get saturated easily. So typically in data lakes, we want a very scalable storage system with a lot of disks. And so traditionally, if you were going to create a data lake on premise, we would create it using Hadoop. We would install Hadoop on premise, and then we'd give Hadoop a bunch of nodes. And that the product in Hadoop that we would typically use is called HDFS, or Hadoop Distributed File System. And then we would have storage attached to those nodes, and we would just throw all of our files at Hadoop into this distributed file system. And then HDFS would never run out of space on us. We would always have plenty of space, and if we ever did look like we were going to run out of space, we would just add a node with more storage, and then add a node with more storage. So that method of like adding storage is a lot cheaper than the traditional method of having storage, which is like using SANs, like storage array networks, where if you've ever run out of space on a SAN, you go back to your SAN vendor and they say, well, you know, that's $1 million, right? Like that's not digestible. Nobody wants to hear that, right? And if you said, oh, we need to spend $1 million to get more SAN storage, the business is going to say, why? Like, what's valuable there? And if we answered and said, we don't know what's valuable, we just know that the data analysts want to get access to more data, the business would say, we can't afford that. Like, we're not going to spend money to upgrade the SAN because of that. But in a data lake over Hadoop or HDFS, if you said, hey, we need more storage because the analysts think there's data that's valuable, we don't know, but we're looking. And how much is it going to be? Well, it's going to be, 10 grand. Or 20 grand or 30 grand. That's far more digestible than those large SAN bills that we used to get. So consequently, we start using the data lake as kind of a data junk drawer. I mean, nobody likes it when I say that, but it's kind of like, hey, we've got all this sensor data where stuff's coming in off of the air conditioning system in a clean room, and we might want to store that. Are we using it? No, we're not, but we might one day dump it in the data lake and forget about it, right? Or oh, we've got all this information about YouTube video views of these videos our marketing department's making. And do we want to store that information so that we can analyze it? Throw it in the data lake, we'll worry about it later. So like I mentioned earlier, the traditional way of doing data lakes on premise is Hadoop HDFS installations. But actually, it's kind of a pain to deal with all that storage on premise. And so data lakes become very easy to implement in the cloud. And Amazon has a whole reference architecture for putting a data lake in the cloud that structures usually around Amazon S3, which is, obviously their storage network. And Azure had a data lake reference architecture that was referenced around Azure Blob Storage, which is, Azure's very first or second product that they released, right? And it's perfectly possible to implement data lakes using AWS S3 or Azure Blob Storage. Perfectly possible to do that. And people have done it with great success. And then they put tooling over the files that are stored in Blob Storage or S3 to make it easier to query. On the Amazon side, they've got a product that's very, very popular called Athena that they're using for that. That's built off of an open source project called Presto. And on the Azure side, they've been using, Power BI and, Polybase and now this product. So the reason why I've gone into all this effort to talk to you about data lakes is because I want you to know a little bit more about the traditional data lake word before I talk about the Azure Data Lake product, which is what this session's actually about. So the Azure Data Lake product is actually separated into two separate products. It's separated into one, Azure Data Lake Store, and it's separated into another, Azure Data Lake Analytics. So Azure Data Lake Store, what you're seeing right here, is the file, it's HDFS for the cloud. So just like we said Hadoop on-premise was HDFS, this is a cloud-based file system that has an HDFS API layer that sits over it. Now, why is that important? Because we can stuff all kinds of data into Azure Data Lake Store using the API or using PowerShell. We can store IoT data and Twitter data and web views and clickstream and relational data, and all kinds of stuff can go into ADLS. And then because of that web HDFS layer, we can consume it in a lot of different areas. We can consume it in Power BI, we can consume it in Azure Data Lake Analytics, but, and this is the big but, we can also consume it using any Hadoop product. So if you used Azure HD Insight, for instance, and you wanted to use Hive or Pig or Storm or any of the other tooling that you can get with it, you can consume it using HD Insight. So the gist of what I'm telling you is that you could store data in ADLS and not use it in ADLA, the other Azure Data Lake product. You can use it in a lot of different places. So just because it's in ADLS doesn't confine you to just using Azure Data Lake. In fact, you can even use it in on-premise if you have big enough pipes, like you're using Azure Express Route or something. You could have an on-premise Hadoop installation that goes and gets data off of the cloud. So you're kind of using the cloud as like a some type of extended data storage in case you run out, right? So Azure Data Lake Storage can store a single petabyte file if you'd like, and a petabyte's a lot of data. You can read that here, but you really shouldn't store data a petabyte, because Azure Data Lake Analytics, when it's scanning over a petabyte of data in a single file, actually doesn't perform very well. So the sweet spot for storing data in Azure Data Lake Store is around 256 megs all the way up to about 2 gigs. That's really the area that you want to be in. If you've got these really large files, you might have to, break them up. Just put them there and break them up in order to use them, right? The point of having data there is that eventually you're going to use it. And so you want it in smaller increments in order to use it. ADLS is tuned for batch queries. So which is good because a lot of Hadoop is still batch, and ADLA is batch. It uses Active Directory for security, stores all data in the native format. If it's video data, keep it video. If it's CSVs, keep it CSVs. If it's JSON, keep it JSON. And then, like I said, it exposes that web HDFS API. Am I speaking too fast?
Nope. No, you're fine.
You're good.
I'm fine. Okay, good. All right. So if you wanted to import data into ADLS, let me get out of here for a second, and let me take you over to my Azure portal. And I have an ADLS here. Yep. And I can click on Data Explorer here, and you'll see a bunch of folders right here, right? Like baseball stats has some files in it, right? And I have IIS log stored here, and I have a past demo stored here, and I have, SQL Saturday demo, whatever. Typically what you'll see, one, I want you to notice something. ADLS has a folder, subfolder hierarchy that is comfortable to most Windows users and developers. So that's a comfortable interface. And if I wanted to upload a file here into baseball stats, I could just click upload, and it would say, hey, what do you want to upload? And I can go grab, any file that I wanted and just go ahead and upload it into there, and it would work. So you can, if you wanted to, sit here by hand and upload files into ADLS, you can do that, or you can either use the Azure Data Lake SDK and .NET, or you can use PowerShell to upload these on a script. And that's typically what people will do. is they will you know, script out some type of data load from a staging server or from some type of like vendor server, cross-boundary server. And then what they'll do inside ADLS is they'll have folders, like you could have like raw folder, right? Then you could have like cleaned folder, and then you could have like an export folder. And what you're doing with those folders is you're indicating what condition the data is in. And it's really important to indicate the condition of the data so that the analyst knows what to expect. If you have a folder called clean, that you're telling them, hey, look, IT has touched these files and they've cleaned them up a little bit for you. And if you have a folder called raw, you're telling them, you know, enter here at your own peril. Like this is dirty, right? You could also have like a playground folder where you give every set, every team, or every individual their own folder so they can grab data out of raw, play around with it, clean it, and then store it in ADLS for further analytics later on as they like are using their tools against it, like R and Python and things like that, right? Okay, does that all make sense? You're not gonna answer me, are you? Yeah. So, okay, so if we're gonna store files in Azure, we have two different ways of doing it. We can either store files in Azure Data Lake Store, or we can store files in Azure Blob Storage. And really, as they add features, one over the other, the reason why you'd use one versus the other is getting a little grayer. But the gist of it is this: if you have a lot of small files, remember I told you ADLS's sweet spot was 256 megs to 2 gigs, right? So if you have a lot of tiny files, you could put them into blob storage, and then you could run a process that consolidates them into larger files that you put into ADLS. Azure Blob Storage tends to perform better over a lot of small files, and Azure Data Lake Store tends to perform better over larger files. So you could read all these differences. ADLS is more expensive because it's tuned for batch queries, meaning if you're going to do a batch analysis using a different tool, you will find that ADLS will outperform blob storage. But actually, Azure Blob Storage, remember I told you earlier about the Web HDFS REST API? Azure Blob Storage has released a Web HDFS REST API. So that difference is no longer true, which means that you can run Hadoop and gain access to Azure Blob Storage files. Okay, so if you wanted to get started, I showed you Azure Data Lake Store, but if you wanted to get started with it, all you have to do is go to your Azure portal, hit this green cross, and just put in Data Lake. And when you do that, you will see at Data Lake Store, and you'll see Data Lake Analytics. So I'm not going to provision these, but it's really easy. If you click Data Lake Store and click Create, you answer just a couple questions. Name the service, what subscription do you want it? Do you guys know about Azure Resource Groups? This is a great thing. If you want to create a whole bunch of things in Azure that you know you're going to get charged for, right? And you know you're just doing it to play, and then you want to be able to delete it all when you're done. If you create a resource group, like I could say, hey, this is the Data Arch resource group, right? And then I add all of my things into the Data Arch resource group. When it comes time to tear it all down, I just delete that resource group, and it deletes every product that I added to that resource group. So the RG is just there as a management mechanism. It's there to view the things you stuffed in there, and it's there to manage them. So, you know, if I were creating a new project that had to do with web analytics, I might create a web analytics resource group, and then I could see everything related to it in there. Then I specify a location, and then I specify a pricing package, and I can do pay as you go, or I can do a monthly commitment. Typically, if you're just exploring, you'll do pay as you go because you're not going to stuff that much data in there, and you won't get charged that much. Azure Data Lake is actually crazy cheap compared to other MPP products. And I'll explain a little bit more about that in just a little bit. Okay, so I'm not going to create it, but that's how I created my Data Lake Store that I showed you earlier. Now, if I come back and I create the other product, which is Azure Data Lake Analytics, I put in Data Lake again under my search. I say Data Lake Analytics, and when I create that, I name it subscription and RG, but look what I have here, Data Lake Store. What you're basically doing is you're saying, I created a Data Lake Store earlier, and I want this ADLA account to have full access to this ADLS account. So that's how you connect it. And then, just like before, you can do a pay-as-you-go pricing or monthly commitment. And I'll show you that pricing in just a couple slides. So easy enough. You guys can get started with this right now if you'd like. So Azure Data Lake Analytics is the second product. So if Azure Data Lake Store is the product we use to store data, Azure Data Lake Analytics is the product we use to write jobs to do something with that data. Now we could use HD Insight, we could use the .NET API, but we're gonna stick in this topic to talking about ADLA. So typically the reason why we're manipulating data using ADLA and ADLS is because the data is really big, way too big for SQL Server, and it's of value that is undefined at the moment. So typically, ADLA jobs are used for querying the data, cleaning the data, aggregating the data, transforming the data, moving it someplace else, or maybe even prepping it to put it into Azure SQL Data Warehouse. So, or to put it into Azure SQL Database, or to put it into your on-premise SQL Server, or to put it into a format that's more easily consumed by Power BI, right? So, but you get the idea that we're either staging it or aggregating, and we're using a language called USQL. That's a new vocabulary word. We're using a language called USQL to write jobs that do those four things. So USQL looks like this. And that, if you know, Rob and all you guys, you Kevin, you're looking at this and you're like, hey, I recognize this. Like, I know select entry from where, you know, I know that, right? But what you may not recognize is the variables that are happening. So if you look at line 1 and you're seeing, hey, you know, @log equals an extract from a text file. So this script is going to go to that text file, grab the entry column, and feed it into @log. And then on line 5, @cleaned is a variable, and it says, I want you to get every entry out of the log file that doesn't start with the pound symbol, which basically remove all the comments out of this file or whatever dirty data might be in there, right? And then take that file that you removed all the dirty data out of and output @cleaned, that variable that we used on line 5, to clean.txt using this specific outputter. So that's different in that USQL is more of a scripting language than SQL is. SQL is a declarative set-based language and does really good at manipulating data, but it's not really meant to be like a procedural language. Do this, then do this, then do this, then do this. It suffers when we like put it in tight loops and things like that. So USQL is kind of more of a traditional scripting language. That's one thing I want you to notice. The other thing I want you to notice is this. So if you see like extractors.txt open paren close paren, right? Or how about this, entry.substring open paren 01 close paren, right? And then, hey, bang equals, right? Is that what we use in SQL? Bang equals for not equal to? No, that's C#. And so what you're really seeing in USQL is that it's a combination between C# and the SQL query language. So why would they combine those two? What an interesting thing. Well, you guys are all SQL developers and you guys have a lot of SQL background. So SQL does something that frustrates all SQL professionals. It will, for whatever reason, automatically parallelize your queries. So we know that because when we look at the execution plan, the optimizer looks at the plan and says, oh, that plan would perform better serial, which means I'll do one thing, then another, then another, then another, and it will do a serial plan. And then maybe it'll look at your query and it'll look at the statistics and the histograms and the statistics, and it'll say, you know what, now that query will be better parallel. And what it will do is it will try to do segmenting and desegmenting. It will segment your query, span it out across multiple processors, have each segment of your query operate on one processor, and then it will recombine the results and then move on to the next operator, right? And this process of SQL deciding whether to parallelize a query or not has traditionally been very, very frustrating to database professionals, because the side effect of this is what will happen is somebody will call and say, that query that's been working great for 14 days is now terrible. It used to be 17 seconds, now it's 30 seconds, right? And you look and you figure out, oh, now SQL is parallelizing a query that it used to serialize, or maybe it's serializing a query it used to parallelize, and the DBAs are like, this is terrible, I hate this. They get really angry about it, right? But in C# doesn't parallelize anything without the developer writing code for it. And so that means that a C# developer has to implement some type of synchronization or blocking and locking code in order to make the processor spike across all of its cores. And so when a C# developer chooses to parallelize something, they have to put a lot of effort into making sure that that happens. And they know that that area of code is prone to bugs. And so if there are bugs, they're very difficult to troubleshoot, very difficult to resolve, and the C# developer gets very good at writing that kind of code because they end up being in that code an awful lot trying to troubleshoot what's wrong with it. So if you went to a C# developer and said, hey, I've got a way to auto-parallelize your code, and sometimes it works well and sometimes it doesn't, but you won't have to be in the code anymore, the C# developer would look at you like that was black magic. They would think, oh, I would love it, right? So it's kind of funny, this magical thing that SQL does, the optimizer does in SQL Server, is frustrating, but it is, let's just give it some props. It really is a magical thing that the SQL developers and product team have done, and we should be grateful that it can do that. Well, what uSQL is uSQL combines the auto magic parallelism of SQL with the kind of mature and robust language of C#, where you can gain access to the .NET framework, you can implement things in C#. And that's really what uSQL is, and that's why they unified it, so that you get a highly customizable and extensible way of using SQL where things can be much, much faster. Okay. So we've already looked at this. Now, the problem with kind of demoing Azure Data Lake is that the jobs all kind of run a little bit slow. So if I take this query here and I go into ADLA, so I've got an ADLA thing called ADLA Ike here. And if I, oh, sorry, that's my ADLS. Let me go to ADLA, ADLA Ike, yep. And if I click new job and I paste that query that you saw on the slide into there, what this is doing is it's taking a file called baseball CSV, and it's finding these things out about the file. And now it's got rank and player name and age and team and league. All of those things are in that file. If you wanted to prove that, by the way, we could just go to ADLS, and we could go to our Data Explorer, and we could go into baseball stats, and we could go to baseball CSV, and you can see it. That this is the file as I was describing it earlier, right? So you can see it. Okay. So if I go back and I go to ADLA and I run that job that I just told you about, right? I am actually putting a schema over it, and then I'm just outputting it. Now you might look at this and say, why on earth is he reading data and then not even manipulating it and then putting data back out? Well, this is a very good first step in uSQL. It tells me that security is working. It tells me that I'm reading the file correctly, and it tells me that I can write where I want to be writing. So in troubleshooting uSQL and in messing around with it, it's very good to start very simple. Like, don't try to get super fancy, just like, hey, can I read and write? And then what you do is you click this button, submit, and it will submit that job to ADLA, and it will run. Now, I want to call your attention to this AU thing right here. And what you'll find is it says estimated cost is 3 cents a minute. Well, it's 3 cents a minute per AU. This query will take less than a minute, so it'll cost me 3 cents to run this query. If I scale this all the way up to 250, now it's $8.33 a minute. What am I doing here? What is this? I'm specifying my degree of parallelism for this individual query. Now stop right there, because this is amazing. In a traditional Hadoop installation, you and I would meet in a room and we'd look at our data and we'd say, how many nodes do we need for Hadoop? And we'd say, 5. And we'd go and we'd buy all the hardware, we'd configure it all, we'd put our data on it. Oh, we guessed wrong, we only need 4. Well, now we've spent 20% more money than we should have, right? Or if we say, oh, we guessed wrong, we need 10. Well, now we need another month or 2 to go buy the other hardware, get it in, install it, partition it, move the data around, right? So guessing parallelism wrong is expensive. That's one thing that's wrong. The second thing that's wrong is your degree of parallelism never changes. If you have 8, you have 8. If you have 4, you have 4, right? It's very difficult to change it. It's even difficult to change it in Azure's MPP solutions like Azure SQL Data Warehouse. If you change it, there's some degree of time it takes to change the number of nodes in Azure SQL Data Warehouse. And it's not done by job. It's done by installation of the product, right? And if you go to HD Insight, the same thing. You go to HD Insight, you pick your nodes, boo, 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 boo. If you need to change it, that's an active decision of changing that thing. And it takes time to do it. And you get charged whether or not you're using it or not, right? If you want to stop getting charged for Azure SQL Data Warehouse, you have to actually pause it to stop getting charged for it, right? Well, what's happening in Azure Data Lake Analytics is far more powerful. What you're seeing is I can choose the degree of parallelism based on the query, which means for some queries, I might only want to run on 1 node, and for other queries, I might want to run on 30 nodes. And I will only get charged for the query running. I won't get charged at night or anytime there's no queries running, I won't get charged. So that is a great way of keeping costs down. It's also a great way of experimenting with the degree of parallelism necessary to get the best performance at the lowest cost. So it's an amazing feature that we have, and it makes it very cheap to play with ADLA. So in HD Insight, I'm going to tell you right now, if you leave an HD Insight cluster on over the weekend, you're going to pay $200. Now, when I tell the average developer that doesn't make them super excited to go learn Hive or learn Kafka, right? Because they're going to be paying for that, or they need to get their company to pay for it. But if you mess around with ADLA, you'll pay $1 or $2 and you'll learn a lot. So it becomes much easier to kind of digest. Okay. What else can I tell you about this? Oh, when talking to Microsoft employees, I meant to mention this earlier. When talking to Microsoft employees, ADLA was a product that was internal to Microsoft and used by MS employees for years before they made it public. So this product that I'm showing you has been dogfooded by Microsoft for a very long time by internal resources. They called that product, when it was inside Microsoft, they called it Cosmos. And Microsoft employees still have a tendency of talking about Cosmos. The problem with that is Cosmos DB is a whole different product in Azure for document storage and graph storage and things like that. So I don't want you to get confused when a Microsoft employee talks about Cosmos. Sometimes they're talking about ADLA. They're not talking about the Cosmos product that Azure has. Very confusing, and I'm really sorry. Okay, so when we click submit, you'll never guess what it does. If you look on the upper left, it prepares, queues, runs, and done, right? So it basically is parsing it, queuing it up and running it, and then finishing it. Does that sound familiar to you? Is that what the SQL optimizer does when it tries to execute a SQL command? Right, so you guys know this. Now, I could sit here and talk for 30 seconds while this runs, but it's kind of boring. This one's kind of boring because it's just gonna go get data and then and then write data, right? Instead, let's just run a different script here. Now, this, oh, see, it's going green already. Oh, and look at this. This little thing up here, this is the useSQL, this is ADLA telling you exactly what it did to get that working, right? And, or what it's about to do. And that's very similar to an execution plan. So you guys are familiar with that. Okay, I'm gonna start a new job. We're gonna do a little bit more here. Now what I'm doing is I'm saying, hey, go extract it like before, but instead give me all the records in that file where there are no, where there are home runs, and then output it to the best hitters have home runs, right? And we could run this, for sure we could run this. So let's go ahead and run it. We'll go ahead and submit, cost me 3 cents. And now this is gonna fail pretty quickly. And the reason why it's gonna fail, I could sit here and wait for it to fail, but I actually do want to show you this failure because the failure is kind of cool. If you're going to experiment with ADLA and use SQL, you're going to fail a lot. And so it's probably good for you guys to get a little comfortable with what a failure looks like. Sometimes we have to like refresh. Okay, it says blah, 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 blah. You've got a problem. I don't know what the problem is, but it's on line 14. And it comes down and you can read the script here, but instead you can go to your script and look at line 14. That's where my problem is. If I click reuse script, I can tell you what the problem is. It's that useSQL is case sensitive. What? Yeah, useSQL is case sensitive. Why is useSQL case sensitive? Because Csharp is case sensitive, and it's carrying that over from Csharp. So if we just simply uppercase what we know we're supposed to uppercase, and we put like a semicolon where we know we're supposed to put a semicolon, and then we go ahead and submit that again, that will run. Okay. So we can sit here and talk while that runs, but I just wanted to show you some other cool things that it does. If I do new job here, this is the same query, only this time I'm doing a group by. Look, we can do group bys here. That's cool. All right. So I can name this just so that we can track it later. Group by, and then submit that. And now that group by job will run. What do you think? If I go start a new job, yeah, that's okay. If I start a new job, will this job run? Look at that job and tell me, from what you know about useSQL, will that run? And the answer is, just from what you know, it will not run because right there, we need a semicolon, boop. But we also have one other problem, and that is here, there is no default join. So you either have to explicitly do an outer join or you have to explicitly do an inner join. So I think those are really, and then the last thing is, do you see this where it says max, boop, 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 right there? You have to use as your alias. So that's another difference from T-SQL, is the as is no longer optional. So if we do that, excuse me, let me just grab a script I know is good. We can go ahead and submit that, and now that will run. Okay. In addition, you've seen me over and over in my new jobs, and if I go on the script, you've seen this syntax right here, where I'm getting a very specific CSV, right? Now, you might not want to do that for each CSV that you load into ADLA. So what you can do instead is do something like this, which says, please go into that folder, IIS logs, and run this for every file in the folder, and put this, schema on read, this schema over it, so that you can manipulate it later and then output it someplace. And we could say IIS log, all IIS logs, right? And we could submit that one too. All right. So here's some useSQL. Oh, by the way, keep running these jobs. Are they actually running? Well, if we go to my view all jobs, you can see that, yeah, these jobs are running. Look, that group by worked. And when we open this up, it says, hey, when I did that group by, this is what I did. And you'll notice that when it says what it did, it says, I needed one vertex here. Well, that vertex is telling me that ADLA decided it didn't need to parallelize that. So if I want the best performance for this query, I can probably get away with only doing one AU with it. But if it said all of a sudden, oh no, I'm using 12 vertexes here, then maybe I need to increase my degree of parallelism when I run this query to get better performance, or maybe lower cost or something like that. So you can see the script that it used right here. And then under data, you can see that it inputted baseball CSV. We've seen that already, but it outputted besthitters.txt. And if I click on that, this is showing the number of home runs per team, right? So you can see like San Diego, Padres, that's where I'm from, San Diego, had one of their hitters for 2016 had 28 home runs. And if we click back here and we look at the script, you can see that group by team looking for max home runs actually did its job and it outputted that file the way we expect. Now, here's some, hey, don't do that. So here's some USQL tips. Remember it's case sensitive. Remember we're using C# data types, so string instead of varchar. We're using C# comparisons, like including that double equal sign. And we can compare nulls, unlike T-SQL where we can't. In USQL, we can compare nulls. Now, a typical USQL job follows this kind of pattern where you extract some data, you assign the results to a variable, you create a schema, you use the schema, you filter and aggregate, and then you output. That's it. So you'll see USQL job examples over and over and over again that kind of do that. Now, with that said, and you've seen me use the Azure portal, but you can also use Visual Studio Code. So this is some example USQL in Visual Studio Code. And I've registered my Azure account with Visual Studio Code. There's a documentation on how to do that. But if I right click here, look, I can submit a job. I can compile a job. The one cool thing about Visual Studio Code over using the Azure portal, well, one, you can have your folders with all your files and you can keep them and run them and keep them and run them. That's much better, right? Two, you can debug these jobs in Visual Studio Code. And three, you can actually format the code here. So you can like automatically format the document and it will know the USQL syntax and put it in the right format for you so that it's easy to read. Then you could right click and you could submit the job and it says, where do you want to submit it? I want to submit to ADLA Ike. I want to use baseball stats. I'll use, the DBO schema is fine. And now it'll do its job. Cool. Okay, so that is Visual Studio Code. In addition, we can write jobs in Visual Studio as long as we have the Azure Data Lake SDK installed. So this, I'm giving away the punchline. So this is USQL just like before, right? And look, I can say go to ADLA Ike, pull down my database, go to baseball stats, go DBO, and I could submit this job. I can also go to advanced and I can change the degree of parallelism for this job too if I'd like to, and change the priority if I'd like. Now, I can run it right now, but I want to call your attention to something that's going on here. On this line, you'll see my USQL application, Ike tools, find the best team, and I'm feeding h.team from my hitters variable in order to get a result here. So I wrote a custom method that took an argument and returned a result, and that returned result that I've embedded in SQL will then get written out in my output file. Now, what did I do? Well, I wrote this in a C# code behind. So every single USQL script has a C# code behind it. Now you can choose not to use it, but it does have it. And so in my USQL projects in Visual Studio, I can create all kinds of different methods and usable tools, like if I wanted my own outputter, or if I wanted my own extractor, or my custom aggregate function, or whatever I'm doing, I can write that in C# and apply it inside uSQL and use it in all of my uSQL scripts, and then put it in these uSQL projects for reuse. That's pretty powerful, I think. In addition to that, and by the way, I'll submit this. We can run this if you want. So if I go back to my uSQL script, go ahead and submit, see if it runs. All right. So in addition to that, I also have this added benefit. This is a uSQL catalog, and it works very similar to like the Hive catalogs in Hadoop or the external tables in Polybase. What I'm basically doing is creating a schema over files for reuse. So if I don't want to continually create schema over files, but instead I want to create a global schema over files so that all the analysts are using the exact same schema all the time, and we know they're not having typos or making mistakes when they try to consume it, I can use catalogs to create tables, to create views, functions, and store procedures. And the syntax for doing that looks kind of like this. Let's see. That doesn't show what I want to show. It looks like this. I'll put this back in the portal. Okay, so just like before, where I do the extraction, what you see here is I can create a table, best home run hitters per team, and I can put an index on that table. And then I can extract data, and then I can take that data and insert it. So I'm extracting data from the file, and then I'm inserting that data into the table, and now I've got that table that I can go, play around with and use. And that works, and it works great. Okay, let me go back to my ADLA account. Let's go to View All Jobs. And that last job where you saw where I was going to look for the late great San Diego Padres. I know I'm jumping around a little bit, but part of the reason why I'm jumping around is because I don't want to sit here and wait for these jobs to take a minute or two each time they run. Okay, so that last script that I did where I had a C# code behind, what it did was it created an assembly here that it loaded with my script, and then it did the regular script that you'd expect it to do. And then it said, okay, I took that baseball stats, CSV, and I outputted best hitters with names. And now you'll see that the names for the teams are all the same like they were before until, oh, I don't see that it worked. Pitt, is it because, you know what? It might be because it ran off to the next screen. So if I want to look at the whole file, I go to my ADLS account. I go to Data Explorer. I go to, actually, where did I put that? What's the path there? I put it in output, best hitters with name. Okay, output. So if I come back to ADLA, go to Data Explorer, go to my output, best hitter with names. Okay, and now what you'll see is this is the data file, and then here, Will Myers is the guy that had 28 home runs, and instead of that 3-character team name that we had before, you'll see that I took it out and replaced it with the great San Diego Padres, which if I go back to my code, is exactly what that code behind does, is it just takes that code and then returns, if you find SDP, return the great San Diego Padres, because everyone knows that's the best team, and they have the smartest fans and the most handsome people in attendance. Okay, so there we go. All right, I'm speaking fast because I'm only supposed to take an hour, so I apologize for speaking so fast. We can, in the uSQL catalog, we can create views, we can create functions, we can create procedures. We can also, in C# create a code behind assembly. So if you have a bunch of functions like tools that you want to use all the time, you can create a DLL and you can deploy that DLL into ADLA, and then you can call it anytime you want from any script you want, even if you don't have access to the DLL in your project. So that is pretty amazing, I think. And we've seen code behind, custom assemblies, and that's about it. So this slide deck is available for download on my SlideShare. If you go to www.ikeellis.com, www.ikeellis.com, and you can see my SlideShare right here. And if you click down, you don't have to go very far before, let's see, dive into the Azure Data Lake, 43 slides. You can go look at the slides, see all the code, whatever you need. And my time's almost up. Are there any questions?
Yeah, you got a couple in here. The first one is, are you suggesting that Azure recommended use of HD Insight and MapReduce is deprecated in lieu of ADLA?
No, I'm absolutely not suggesting that. No, I was talking about the differences of HD Insight and ADLA. And the difference is HD Insight is great. So here's the main issue, by the way. Hadoop is hugely popular. I mean, it is everywhere. And people are using it in all kinds of organizations for all kinds of purposes. But for whatever reason, Hadoop has not gained a lot of popularity with Microsoft developers. It's hugely popular with Python developers, Scala developers, MySQL, Postgres developers. All of these developers have gotten on the Hadoop train, but Microsoft developers have not. And so I am suggesting that ADLA is an easier introduction into MPP analytics and cleaning, because what ADLA is Hadoop Yarn being repackaged with C# and USQL. So it makes it easier to get into, and it makes it cheaper to get into. But look, if you have a Hadoop team and they know it really well, and you want an introduction to get your Hadoop cluster into the cloud, HD Insight is a great way to do that. I'm a huge fan of HD Insight. I love the team. They're responsive. They're doing a lot of great things. And I use them. I help them write some of their documentation. So anyway, hopefully that clears that up.
The next one is, what about Java-based Linux apps that aren't so C# and .NET based?
Well, so the Data Lake team, there's no Java solution that I know of. Maybe they've released something. Azure changes so frequently. I don't know what might have happened the last month or two, but they do have a Python mechanism for using ADLA. So they are maturing other languages. Oh, and remember, keep in mind that ADLS is usable by anything that can use the Web HDFS API. So you can, all those Java apps can use ADLS. It's just ADLA they can't use.
Okay. And then I'm looking at the remaining questions in the pane here. They look like they might need some more in-depth answers. If you don't mind, Ike, I'll package those up and send them along to you.
Yeah, I'm not sure how I'll get the responses back to them, but you want to cherry pick one or two and see if.
Let's see. This one's actually kind of interesting. If I have quite a few small files, less than 200 megs, that I need to send to a data lake, then process, aggregate, and then send the results to a data warehouse, should I use blob storage instead of ADLS?
I think so.
Okay.
Yep, I think so. Try them both. I mean, if they're smaller than 256 megs, you'll have to, bundle them up if you want good performance. It's only for performance, right? I mean, you can do it in ADLS and it'll work, but it just might not perform as well as you hope.
What is the relationship between USQL and Polybase?
There is no relationship. So Polybase, if you haven't used it, is a SQL product that exists in SQL Server on-premise and Azure SQL Data Warehouse that allows you to ingress large amounts of files into your relational database. And the way you can ingress them is you can interact with those files using T-SQL. So the same way you're interacting with your relational data, you can interact with those files. Now, the primary reason to use Polybase is to get that data prepped to go into the relational store. It's really not to leave the data there for long-term analysis, because the first thing Polybase does is it loads it all up into memory. ADLA is different. uSQL uses ADLA, and uSQL pretty much keeps the data where it is and queries it using WebHDFS where it is. That's a lot different. That's a different design, right? But it can also prep it in ADLS and emit it to ADLS in preparation to put it into Azure SQL Data Warehouse or some other thing. Or it can leave it there and you could put it into blob storage or something and put Polybase over it and ingress it from Polybase if you'd like. A lot of different options of doing the same thing. But keep in mind that Polybase's language is T-SQL, not uSQL.
All right, and then the last one I have is, how do you choose between Azure Data Lake and Azure Data Warehouse?
Well, Azure Data Lake is far cheaper for Azure Data Lake Store, and it is meant for a bunch of unstructured data or data that you're unsure if it's clean. Azure SQL Data Warehouse is primarily relational, which means when you've got the data in a relational state, you pretty much know it's clean, or you know it's getting clean, right? So you've done a lot of work to get just regular data into a relational store. You've done a lot of work to do that, right? So they're really, you let, for instance, if the data is already relational and you have the money to afford Azure SQL Data Warehouse, you're probably going to keep it in Azure SQL Data Warehouse. If the data is relational and you don't have the money for it, you're going to spin that data off into CSVs and blob storage or ADLS. And then in order to analyze it, you'll have to use ADLA or HD Insight or Polybase to analyze it. So that's how I guess that's how you choose. If it's relational already and you have money, you'll put it in SQL Data Warehouse.
I think that's it, right?
We have one more that just came in. It's data is rarely between 256 megs and 2 gigs. How do you use blob storage in lieu of ADLA?
Well, again, that was just me giving best practices. I wasn't saying that you had to do that, right? But I was offering, like, look, if you're doing batch processing, if you have a lot of small files, there's overhead, right? There's like, where's that file? Do we have security? Do we have to do an authentication check? Like, if you've got a ton of small files, doing that authentication check per file, the way ADLS does it, there's overhead to that. Where in blob storage, you do the security based on the container, right? Not based on the file. So it's fast. That's one of the reasons why it's faster for smaller files. But so I'm sorry, what was the actual question? I wanted to clarify, I'm not saying don't use it if it's not in that range. I'm saying that's the sweet spot for performance, but you could certainly use it out of that range and be fine.
I think that clears it up.
Okay.
Hey, Ike, thanks for coming on today. This has been great.
Good. I'm glad you liked it.
Oh, yes. Well, I want to thank everyone for coming today, and especially thank Ike for giving an hour today. And it's been a great webinar. And I look forward to everyone coming to the next one next month. Thank you. Thank you, Ike.
Yep. Thank you, Rob. Thanks, Kevin. Yeah. Talk to you guys soon.
Okay, bye.
Bye-bye.